Assuming you place it in a way that it faces the Sun, it would relax the beast that is Jupiter's orbit, utterly uneasy and headed to detonate. This is one of the most popular effects of radioactivity that can be seen in the entire universe, emitting more energy than 1 billion suns. A red giant is a terrifying jewel of a star that crawls. If it were situated where the Sun is, it would be a member of the Jupiter group, enormous and also completely erratic, going to burst into flames. When we consider stars, without a doubt we envision bright things that shine in the night sky. In essence, this is the procedure. We can still see them from Earth, whereas stars are entirely distinct. In fact, one of the most prominent stars, Betelgeuse, is substantially more significant than our Sun. This star has existed for a very long time and has confused researchers. But in actuality, something more troubling has been going on with Betelgeuse, making examiners and other scientists extremely concerned. Join us as we conduct in-depth research on this excellent brand new information regarding Betelgeuse. It explains precisely when this discovery will result in destruction, typical of the James Webb Space Telescope. The course of this new development influences both our lives and the universe, as explained by physicists. Betelgeuse is everywhere on Earth, including in the minds of people like Michio Kaku. It's a fantastic wonder, a massive star that has captivated astronomers for such a long time. A long-time Greek astronomer, Antonius, was the first to locate this star. It is so enormous that it might be considered one of the most prominent in the night sky. If you're interested in cosmology, you've probably seen or heard of this star. In winter, it appears orange-colored and is situated in the upper left shoulder of the constellation Orion. This makes Betelgeuse one of the most stunning stars at night. But something about it is unsettling. The beauty of Betelgeuse is that it no longer maintains stability. It has altered one of its best characteristics, its variability. But we should examine a few of the particular characteristics of the majority of stars. The stars you see in the night sky are very distant. The closest star to Earth is 4.2 light-years away. If you are unfamiliar with light-years, consider moving at the speed of light for a year. Light travels at approximately 186,000 miles per second. As a result, the distance light can cover in a year is enormous, billions of miles, which indicates that the closest star is still billions of miles from Earth. Some stars are even farther, including Betelgeuse, which is approximately 600 light-years away. If you somehow traveled at the speed of light, it would take 600 years to reach it. However, we cannot move that fast, not even in our fastest rockets. Though Betelgeuse is so far away, it still shines brightly in our sky. I'm puzzled as to how it can be so impressive despite the distance. It is due to its unique characteristics, such as brightness and size. Betelgeuse is many times larger than our Sun. Its radius is significantly greater. However, through present telescopes, it appears distorted in space, whereas other stars are tiny points in the sky. This is probably because of its outer layers. Betelgeuse weighs between 12 and 19 solar masses. The standard unit of mass used by astronomers is a solar mass, which is approximately equivalent to 2 times 10 superscript 3 kg. Researchers cannot pinpoint the exact mass of Betelgeuse due to the fact that there are no planets orbiting it. Despite this, Betelgeuse is reputed to be significantly larger than our Sun. It varies in brightness, sometimes increasing, sometimes decreasing, over time. This pulsation cycle can last anywhere from 10 to 100 days. One unique characteristic of Betelgeuse is that its surface is covered in dark magnetic spots. These magnetic fields are much stronger than those on the usual surface. However, they hinder the flow of hot gas to the outer layers of the star. This results in cooler regions on the star's surface. Compared to our Sun, Betelgeuse has an abundance of these magnetic spots, which contribute to its cooler temperature. The Sun also has dark spots, but Betelgeuse's are significantly larger, sometimes twice the size of Earth. Additionally, Betelgeuse possesses a potent magnetic field that is numerous times stronger than that of the Sun. This field causes its outermost gases to appear as if they are bending or swirling when viewed through a telescope. Betelgeuse has a surface temperature of approximately 3,500 Kelvin, which is relatively low compared to other stars. This lower temperature gives it its characteristic reddish color. But it was not always red. About 100,000 years ago, Betelgeuse was yellowish. Over time, similar to our Sun, its color began shifting to orange-red, and about 10,000 years ago, it fully transformed into the red star we see today. Because of this shift, researchers think that Betelgeuse is changing. It generates substantially more energy than the Sun, which, if it came any closer, would outshine the Sun. However, because it is 600 light-years away, it remains just a luminous star in the night sky. In contrast, our Sun only produces light 8.3 minutes away from the planet. So even at such a vast distance, Betelgeuse shines so brightly. If Betelgeuse were closer, it would dominate our sky, even during the daytime. Significantly alter its orbit because of its enormous size. Regardless, it emits significantly more radiation than the Sun due to its sheer size. Betelgeuse is a giant star located in the Orion constellation, approximately 600 light-years from Earth. Due to its enormous size, one of its most recognizable characteristics, astronomers worldwide continue to be fascinated, and even intimidated, by it. Astronomers have long studied Betelgeuse because it is a red supergiant, unlike our Sun, which will eventually grow into a red giant and then shrink into a white dwarf. Betelgeuse, however, is large enough to end its life in a massive explosion, a supernova. The question that scientists find most fascinating is, when will Betelgeuse explode? The truth is, no one knows exactly. However, researchers estimate that it could occur at any time in the next 100,000 years, which, in cosmic terms, is the blink of an eye. Some people even believe that the star may have already exploded, but since we are 600 light-years away from it, we wouldn't see the explosion until the light reaches Earth. What will happen when Betelgeuse goes supernova? When Betelgeuse finally breaks apart, it will be one of the most stunning cosmic events ever witnessed. The explosion will be visible from Earth, so bright that it could outshine the full moon for weeks or even months. It might even be visible during the daytime and seen clearly with the naked eye, even in city skies. The explosion will eject a tremendous amount of energy, matter, and radiation, producing shockwaves through space. Despite its strength, Betelgeuse is far enough from Earth that its detonation won't directly threaten our planet. The most noticeable effects will be the incredible light, the cosmic display, and potential increases in cosmic rays. How do scientists monitor Betelgeuse? Betelgeuse is closely observed using some of the world's most advanced telescopes, including the Hubble Space Telescope, which captures detailed images of the star's outer layers, and the James Webb Space Telescope, JWST, which sheds light on its infrared emissions and dust formations. The Very Large Telescope, VLT, and ALMA observatories also measure its brightness fluctuations and mass loss. Recent observations revealed that Betelgeuse dimmed significantly toward the end of 2019 and early 2020, leading some astronomers to believe it was about to explode. However, further research showed this dimming was due to a massive cloud of dust ejected from the star, temporarily blocking its light from view. What happens after the explosion? When Betelgeuse explodes, it will leave behind either a neutron star, a superdense rapidly spinning remnant, or, if massive enough, it could collapse into a black hole. The supernova will also enrich the surrounding space with heavy elements, assisting in the formation of new stars and planets. This process is crucial to cosmic evolution. Many of the elements found on Earth, including those in our bodies, originated from ancient supernovae. Final thoughts on Betelgeuse. Betelgeuse continues to be one of the most fascinating stars in our galaxy. It has puzzled astronomers for hundreds of years and continues to do so. Whether it explodes tomorrow or in 100,000 years, one thing is certain. When it does, it will be one of the most spectacular astronomical events ever observed by humanity. Until then, scientists will keep their eyes on this mysterious red supergiant, patiently waiting for the moment it succumbs to its fiery destiny. More about its size and nature. Betelgeuse could easily encompass Jupiter's orbit if placed at the center of our solar system. Its enormous size is more of a warning than a wonder when viewed through powerful telescopes. Yet, despite its enormity, Betelgeuse isn't the largest star in existence. Its mass ranges from 12 to 19 times that of the Sun. This variation is due to the difficulty in measuring stars that lack nearby companion objects for gravitational reference. Even at the lower estimate, it's an immense celestial body. Another remarkable feature of Betelgeuse is its brightness variability, which fluctuates over the years. Its magnitude ranges from about 0 to plus 1.6. At its brightest, it may appear multiple times brighter than our Sun, due to internal cycles of expansion and contraction. Its surface and final phases. Despite its massive size, Betelgeuse's surface temperature is relatively cool, around 3,500 Kelvin, giving it the distinctive red hue typical of red giants near the end of their lives. It has exhausted its core hydrogen and is now fusing heavier elements, which causes it to expand further. Its atmosphere is brimming with magnetic activity, including dark spots where convection is suppressed. Even so, the star remains brilliantly luminous. Eventually, it will run out of fuel, triggering extreme fusion processes and forming heavier elements like helium and carbon. This leads to further expansion, followed by a catastrophic collapse. A supernova. Supernova impact. A supernova explosion releases enough energy to momentarily dominate an entire star system. The shock waves it produces could trigger the formation of new stars. While the Betelgeuse supernova is not imminent, scientists are watching closely to better understand stellar evolution. When the explosion occurs, Betelgeuse will eject its outer layers into space and leave behind a dense core, either a neutron star or, if massive enough, a black hole. The supernova will disperse heavy elements like nickel and iron, which are essential for forming new planets and celestial bodies. This contributes to the continuous cosmic cycle of life and death. Legacy of Betelgeuse. Though we may not be alive to witness its final moment, studying stars like Betelgeuse provides vital insights into stellar life cycles and the dynamic nature of the universe. Its eventual demise will not only mark the end of one of the largest stars visible from Earth, but will also pave the way for new celestial formations. These events help scientists understand the cosmic forces shaping our universe. Astronomers will continue using cutting-edge observatories to study Betelgeuse. Its supernova, whenever it comes, will be one of the most captivating events in human history.